Hi, my name is Kenneth Earls, and today I'm going to be calculating the angular speed of a computer fan. I've decided to do this by taping the fan to the inside of this box. I've broken a couple of blades off just to ensure that there's enough time in between each rotation where there is a patch of light and dark spots that the oscilloscope can measure with the photoresistor. I've stuck it inside this box to make sure that I can isolate it from ambient light. And this is what my circuit looks like. I'm using a quarter Wheatstone bridge with a 3.3 volt power supply from the oscilloscope itself. It's connected to my power rails here, and I have the positive on one side of the Wheatstone and the negative grounded to the opposite end here. These are four 5K ohm resistors on either side of my photoresistor. Each one is in parallel with itself, connected to the photoresistor, and then these two are in the same way on the other side of the resistor. My signal cables are positive to one side of the photoresistor and negative ground to the negative rail. I'm going to be powering my fan with a 5 volt supply from the wall and this power source here. With the box and the fan covering the circuit, I expect that there should be no change in the voltage signal. But as I introduce light to the circuit, I should see an increase in resistance corresponding to an increase in voltage. And I do. If I move the light back and forth over the hole, there should be waveforms. Now I'll turn on the fan. You can hear the fan going, and as I put the light in, we should see some nice waves form on the screen. Now I can pause our readings, and I can calculate frequency based on the number of peaks per second. So here I have 5 blocks, each 0.2 seconds, so I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 peaks. That means we have an 11 Hertz signal. So my 11 Hertz signal gives me 660 RPM. I can reason this may be an accurate answer considering that at 12 volts, which is the spec power rating for this fan, it operates at 2000 RPM. Checking the ratio of voltage to fan speed between our spec values and our measured values, see that we get a ratio of 167 for the spec and 132 for our test. This is pretty close, and I think it may be a good approximation to say that this test is good if I can correctly assume that the proportion between RPM and voltage is the same across all the voltage ranges set for this fan. Maybe lower slightly because the fan is broken. The few fan blades that I did break off are causing the fan to rattle a lot, so that could definitely halt the fan speed a little bit.